and breathes Kubernetes. So please do feel free to interact with them at the Q&A and ask any questions that you have. Before we start as well, a little bit about BigMind. We provide services and software tools to help companies in their cloud native journey. There are three main areas that we work in. The first one is in terms of discovery workshops. So we run 1 to 3 day programs to help companies solidify their digital transformation and cloud native goals and use cases. We also provide services in terms of advisory and implementation services for your cloud native projects and to help bring them to life. And finally, we also produce cloud native software tools to help you take advantage of today's technologies such as Kubernetes. And one of the tools that we have developed, we will be sharing, you'll be hearing more about in the later part of this session. Okay, importantly as well, just for all of you who've joined us today, there's some important goodies from both Alibaba Cloud and BigMind. From Alibaba Cloud, they've extended a free course in terms of the course is for using Kubernetes to manage containers and cluster resources, and your license key will be emailed to you after the session. At the same time, if your organization has just started out with cloud app modernization or is looking to implement Kubernetes, we can help. So we're doing a free half-day consulting session to help you in terms of establishing organizational readiness, identifying pain points, and what pilot projects you could probably run. An EDM will be sent to you as well after the session, or you can sign up at the bit.ly link below, which is bit.ly/ACK assessment. So do let us know. With that, and without further ado, I will pass over to my colleague, Vinod, to take us formally into today's presentation. Have a great time and enjoy yourselves. Over to you, Vinod.
Thanks, Joanne. Let me get my screen share. A very good afternoon, everyone. I'm Vinod. I work with business to enable them with the right set of products and services in the adoption and acceleration of cloud native practices. So in today's session, we will look at how you can migrate an application from your Kubernetes cluster to Alibaba Cloud's container services for Kubernetes, ACK. The session is intended for audience who have some prior knowledge in Kubernetes. However, if you're new to Kubernetes, you will still be able to pick up some skills around the app and data relationships and management, as well as the steps on migrating your workloads compared to VM. So the key takeaways for today's session are: one, we are looking at, you will learn about what an application consistent backup means in Kubernetes. Two, we will learn some considerations around migrating your app. Three, you will learn the steps involved in migrating your app. And fourth, you will see how we can simplify the whole migration process through Alibaba Cloud products and the BigMind products. So we'll start with So let's look at some of the migration motivators or opportunities. In the recent years, you have seen a lot of businesses moving their on-prem clusters to managed Kubernetes cluster on public cloud providers. The primary driver behind this has been a cost efficiency and operational efficiency. There are other drivers as well, which is to kind of adapt the scalability, the performance, and security that the cloud providers provide. So in the case of, let's say you have an application that demands high IOPS, or you have an application that demands graphical processing units. So that would be a good case to move your on-prem workloads to Alibaba Cloud, where you could leverage these services on demand. This is the same when it comes to having your workloads running on other public cloud. You would move those workloads into Alibaba Cloud for the same reason in terms of cost and operational efficiency. Or it could be that you are now starting a new business in, let's say, Indonesia, where there are data governance and data sovereignty laws that restricts you to move the data from the country, right? So in this case, you may choose to move your workload from a public cloud provider to ACK. So that's a use case we are looking at. So what if you don't have or you are not allowed to have your production workloads on a public cloud? So in that case, you still may want to adapt some of these cloud benefits. So in this case, what you could do is have your production workloads running on-prem, and then you could have your development and QA workloads running on the cloud. So that's a good use case to migrate your workload. So you could take a snapshot of a production app and have it debug on a managed Kubernetes on Alibaba Cloud, right? So that's one of the other use case you're looking at. Also, you could set up the cloud as a disaster recovery zone, or you could extend it to provide a high availability to your existing on-prem cluster, right? So, the next important thing here is why are we talking about simplifying this app and data migration? What's the challenge behind it? So primarily, when you look at the app and data snapshots within Kubernetes, this is not the same as a disk or a VM backup. So the storage is very application centric, right? So this, what do I mean by that is storage is presented and consumed by the application, not by the OS or a hypervisor, which is the case when it comes to like a VM. So you have a storage provision to the OS and a hypervisor. But when it comes to a Kubernetes, the storage is very application centric. So for example, when you deploy an application, so what the application will demand or make a request to the orchestrator, in this case, Kubernetes orchestrator for a claim. So the claim could be something like, I need a 20 gig of SSD, right? So then the Kubernetes orchestration tool will then talk to the underlying storage and provision this request. So the request is called a persistent volume claim, and then the request, Kubernetes then allocates a volume dynamically, which is called a persistent volume, and that gets attached to the app. So what you see here is more like a dynamic allocation of storage to the application. And so when you look at your storage, which could be backed, let's say you're on an on-prem, we are looking at the storage being backed up by a vSAN. And in this case, you're going to look at a multiple data volumes. So if you think about that, hey, maybe I want to take the volume and then do a volume backup. So there is no way for you to associate the volume back to the app. It's just if you look at from the storage, you're going to see a huge number of these volumes, and there's no way that we can link it back to the app. And also, if you're doing a file system level backup or a file consistent backup, you're going to miss pieces of memory operations or the pending IO operations. So which brings to the point that you need to have an app consistent snapshot so that any pending IO or a pending memory operations are written to the disk, right? So this is the complexity we are dealing when it comes to Kubernetes data migration. So what are the key considerations around migrating your workloads, right, to a public cloud, right? So the first important consideration you need to have is the cluster compatibility. It starts with the versions of Kubernetes. Do you have any application that is specific to the version of Kubernetes? So that you got to make sure that the Kubernetes version on the ACK is able to support your applications. Two, you may have requirements specific to an app, and an app could demand that it needs to run on 3 nodes at any given point of time. And so you got to make sure that you have provisioned the resources as well, right, to have these kind of demands fulfilled. It could be the same for storage. So there could be apps that are demanding for an SSD-backed storage. It could demand for a HSD-backed storage. So you need to look at the cluster compatibility from the Kubernetes version, the storage requirements, the hardware requirements, and the network requirements. So this brings to the next topic in terms of the coverage. What do I migrate? Do I migrate my entire cluster, or should I migrate specific apps within the cluster? It all depends on uh, on how massive your cluster is and how many apps are running on the cluster, right? It is always advisable to go with specific applications because it kind of helps to minimize the risk, and you have a better control over what you move, and is easy to roll back and recover than an entire cluster. Uh, from our experience, when we are dealing with the cluster level backup, the etcd could be a little bit temperamental, and it may not behave the same on the destination cluster if you didn't follow all the right steps. So the recommendation is always to go with specific apps, and which could also be the case in most of your scenarios. Every app would have a different backup requirement, and you may want to treat each of these from the specific application perspective. So that brings to the next topic, which is whether should I migrate it live, or should I be doing that offline, right? So this completely depends on the SLA of the apps, right? So where possible, where you could do a migration with a minimal downtime, that would be good, with minimal disruption. But if you could afford to have a downtime, let's say you may have a non-peak hours, so that would be a good time where you could do like a blue-green deployment, so which is what we will be also looking into today. The another thing is, how do you estimate the downtimes, right? So when it comes to offline, you also want to know what would be the downtime. The natural question is, how do I conduct drills around it? So that's where you will need to look at a tool set that could help with some of these considerations, like how can I run some drills? How can I visualize what is happening behind the scenes? How can I have a visual cue on the progress? So a tool set would help with this, and having a tool set also means that you could repeat the same process multiple times and be comfortable before you move with the actual workload. So that brings to the next question on, okay, now that I have a tool, I perform the migration, how am I going to secure this data? So the data that you backed up is very critical to your business, right? So you need to take care of securing this from the encryption on rest, as well as while you're transferring this data out of your data centers, you need to make sure that's secure, and no one is going to tamper your data. And also you need to look at the compliance. So you may have a governance around moving data into certain regions. So do take care of the governance portion as well. Finally, no matter how much we plan, we have all been in this situation where things could go wrong. So always consider a rollback strategy. Yeah, so do consider a rollback strategy just in case things are just going to fail. So we have looked at what an application consistent backup means in Kubernetes. We've looked at some of the consideration. So the next item we want to look at is what are the steps involved in the migration of an app. And to facilitate this, I'm taking a case study. So a major retail organization has been using Alibaba cloud services for quite some time, and they're happy with the services and the benefits it brings to business. So they're now considering to move some of their on-prem cluster to Alibaba Cloud. And to start with, they're looking at to migrate a to-do app that's in use in the retail stores by their staff during non-operating hours. So Alex, who is the system admin in this organization, is being tasked to conduct this migration. He has a good knowledge of Kubernetes, but his experiences around setting up clusters and maintaining it has not been that great. He had some unpleasant experience. So let's look at what are the choices Alex would make in this situation, right? So starting with the choice of Kubernetes, whether you want to go with a custom dedicated setup or you want to choose a managed Kubernetes offering in the case like Alibaba Cloud Container Service. So definitely the choice here is to go with a managed Kubernetes offering because it removes all the operational overhead of setting up the cluster, maintaining that cluster and updating it. And the business could just focus on delivering and deploying apps. So that overhead is removed, right? So this is a natural choice for Alex to move. For all the temporary data storage and provisioning, we have a cloud object storage service from Alibaba that helps with all the temporary storage and backed by SLA. And since this is just a to-do app, instead of moving the entire cluster, Alex chooses just to move the specific app. And that also helps him reduce the overall downtime. So since the app is only being used during operating hours, he then chooses to have it migrated during the non-operating hours. So he could bring it offline and then move it to the cluster, right? So it all brings to the last point of the GUI-based tool, right? So he needs to look for a tool that could help him automate the process. He could conduct the drills. He could estimate the downtime. So definitely a tool that's more user-friendly and provides the management capability would be the choice for him. So before we go into the details of the migration, let's just profile the app, the to-do app over here. So from a development stack perspective, it looks like a React application with a front end exposed in a React, which then communicates back with a backend service that's written in Golang, and then it's backed by a MongoDB storage. So this is a very high level view of what the application is. So let's deconstruct the app and see what it means within the Kubernetes world. So you can see that the front end is exposed as a service. So there's a front end service where all the other services would be able to communicate. It then talks to the pods. The pods might be running on multiple nodes. And then the front end service has a configuration to say, hey, which is the backend service you got to communicate. So the backend has a backend service exposed, and then it has multiple pods. Then and there is a config map to say which is the database service, and the connection strings for the backend app to communicate with the database are then stored in a secret. And from the database, you can see that it has its data credentials in a secret, as well as there is a claim, a persistent volume claim that it makes. And there is a persistent volume that is being allocated from the Kubernetes orchestrator. So the key, it's very important to understand this view. So when we talk about the application consistent backup, we are talking about all these elements working in a cohesion, right? So if you don't move this entire elements onto your destination cluster, you may experience failures in certain portions of the app. So it's very important to understand what the decomposed view of an application is. So now let's go into the steps, migration steps. So I have split this migration into 3 steps. One, prepare, and step 2 is to do the migration, and step 3 is to do a cutover. So we'll start with the step 1, preparation. So the first thing we got to do is set up the ACK cluster on Alibaba Cloud, and then to back it up with the temporary storage. So we set up the object storage service, and then we install the container registry on Alibaba Cloud. And this is to ensure that the container images are within the perimeter of the cluster for a better experience and performance. Then you would sync your on-prem container registry with the container registry on Alibaba Cloud. So if you have Express Connect or a VPN, all these communications between your on-prem and Alibaba Cloud can go through the VPN or the Express Connect. The point 5 is more of a best practice. If you are able to label your applications on-prem to say, hey, these are my applications that I need to back up, that would come in handy when you do the actual migration in the step 2. So let's look at what happens in the migration, right? So the first thing what we have to do is to create some scripts. So let's call that a backup scripts. So these scripts will need to communicate with the Kubernetes APIs, Kubernetes the container runtime, and as well as the CSI, the storage interface, right? So you need to write the scripts that could interface. And then the next action is for us to trigger the backup. So when we trigger the backup, we need to look for the specific application within the cluster. And then for that specific application, you then need to enumerate all the related resources attached to it. So all your PVs, config maps, secrets, deployments. So all these needs to be enumerated. So it's possible that these are running across multiple nodes. So once you have that information, you then need to package it. And then this package needs to be sent to an object storage, right? So before we send, then you need to encrypt the backup, and then you need to transfer the backup to object storage. And so once you have the backup on the destination cluster, you can then write some scripts to decrypt the package, unpackage, and then install the application onto the destination cluster. So, so what it does is it reinstalls the pod, updates all the Kubernetes objects, the service objects, and then it needs to communicate with the master node on the destination cluster to say, here is your new app, here are the services. And then the last step will be is to configure the app URLs, then expose the service so that the on-prem cluster can still communicate with it. Right? So that's a complex. So you could see that it's a complex step over here. So so how we can simplify this this tedious manual CLI based process is where we bring in Cape. So Cape helps to do all the heavy lifting behind the scenes, and provides you with a graphical user interface that is easier to manage, and you could visualize the progress of what's happening behind the scenes. So it does pretty much that heavy lifting for you. So with Cape installed on the cluster, how does this simplify and what does it look like? So you could see here is that you don't have to write those manual scripts anymore. So it's easy to install Cape, and it runs within your cluster as a single pod. And when you when you open Cape, it will automatically enumerate all your applications and namespace. You can then pick one of the specific application that you want to back up. And when you trigger a backup, behind the scenes, it's going to automatically look for all these service objects associated with the particular app. And then it's going to package it, and it's going to encrypt it, and then it's going to securely transfer it all the way to the object storage. It will also ensure that the storage is compatible across these clusters. And the step two, what you do is on the destination cluster, you're going to open Cape again and point to the backup file, and you're going to just trigger the restore process. And behind the scenes, what happens is it's going to decrypt, unpack the backup file, and it will deploy all the applications. It will associate all the services, and it will also update the URLs and expose the service for you. So, so that's how we simplify this, the step two of the migration using Cape. So the last step after you do the migration is for you to do a sanity check. So you will perform a sanity check on your destination cluster to ensure that the app is running good. And once you have verified, you can then go and update your CI/CD pipelines to point the integration deployments to the new cluster, and then you could bring down your the app on the source cluster. In the next session, Chuck will talk a little bit more on how you could use how Cape could also help with federating the deployments across multiple clusters. So before I hand over, let me just give a quick recap of what we discussed. Right? So we looked into how what an application consistent backup means in Kubernetes, and how the storage is very application centric, right? Then we looked into some of the key considerations. So one important thing you need to ensure is that the compatibility of your applications across the clusters, and two, always conduct drills. So that will give you an estimation of what is the downtime you're looking at, or if there are any issues with the migration. We also looked at the steps involved in the migration, and finally we did look at how Alibaba products as well as Cape can help you simplify this overall experience. Um, yeah, so if you have any questions, please drop by in the Q&A section, and we'll address them towards the end of the presentation. So thank you, and I will hand over the session to Chuck, who will take you through this migration steps and from a demo perspective. Thank you. Chuck, over to you.
Thanks, Vinod. Thanks, Vinod. Thanks everyone for joining in this evening for learning about how you manage your workloads across multiple clusters, especially when you do migrations. I would like to give some details on how you can use Cape for doing the application migration, and as well as deployment of applications across multiple clusters. Unfortunately, I'm not able to show the disaster recovery portion or the migration portion today because of some technical difficulties. But I would like to show the multi-cluster application deployment, which I will navigate and then show it, and use the rest of the time for any Q&A questions that you might have across moving application workloads between the on-prem environments and then to cloud, or between the cloud. If you have any questions, feel free to put it in the Q&A. We'll try to answer as many as possible since we have more time left for that. Okay. All right. Let me just confirm if you can see my screen. Okay. Typically, in most of when you're dealing with multiple clusters or a hybrid cluster where you have a on-prem environment and then a cloud environment, you might need to move some of your workload from the on-prem environment to cloud environment. Vinod has given the gist of how it can be done using a Cape agent, where once you go to Cape management cluster, you can connect all your clusters to the Cape, and then install a component called a backup and DR component. That component is responsible for taking any workload data that is running on your on-prem, and then transparently move it to a different environment using the Ali Cloud object storage as a medium in between. So I would like to table that for now. Also showcase some of the other capabilities as in the multi-cluster deployment. Let's take an example that Vinod started with. You have a shopping application where you have a to-do application here, which is used by most of the retail store employees. And these employees are basically tracking their items to do most of their activities, like daily to-do activities. And this application, let's say you want to deploy to multi-cluster environment where you have a on-premise Singapore cluster, but you want to make this application local to any of the other cloud providers as well, cloud environments as well. Think of it as like different geolocations. Maybe Malaysia, you have one cluster, Jakarta, you have another cluster, Japan, you have another cluster. And then you want to deploy the same application across multiple clusters. How you can do that using Cape is what we're going to see. In Cape, this is how you can connect a cluster. As you can see, I have 3 clusters here. One is on-prem cluster, and then a Malaysia cluster, and also a Jakarta cluster. If I have to connect one more cluster, it's pretty straightforward. You go click on connect cluster here, select the provider that you want. In here, Ali Cloud is my provider. Similarly, you can pick any other distribution of Kubernetes, or it can be your own on-prem Kubernetes as well. I can give it a name. This is a Japan cluster. I will name it as Ali Yon 3, and the location is Japan. Okay. And then I can connect in two ways. One is using kubeconfig, which is you should have a kubeconfig that you can upload to Cape. Or if you don't want to do that, you can also use a kubectl command that we will generate for you, and then you can apply that on your cluster. This is especially useful if you are behind a firewall. So I'm going to select the kubeconfig of the cluster that I would like to connect. So here I have several here. I'm going to select the one that I want and then click on connect here. Okay, that's all you need for connecting a cluster here. Uh, Generally, we prefer to have something like a um, plain Kubernetes secret, as in some of the kube configs are provided with the cloud provider specific authentication details. If in that case, you need to do some more work, but it is as easy as just uploading your secret file, and then you should be able to use your application. Okay, so I'm going to pick my ACK cluster here and then connect. And then within less than a minute, I should see that the cluster has been connected to Cape. Okay, it is now connected and then healthy, and now I can perform two kind of activities. One is backups and DR across all these clusters. So I can take a backup here and then deploy it here, or I can deploy an application to all these clusters at once. Okay, so how do I do that? Typically, if you want to deploy your application to multi-cluster, you have to group them at once, and then you can use Cape to deploy to all these clusters. If you have to do it without Cape, what you do typically is you build a pipeline. That pipeline runs through um, that pipeline has to be smart enough to understand, like to go to all the clusters and then deploy. If there is any change in the logic or any language change or any practices change, you still have to go update that pipeline. And then it is very hard typically for operations to focus on multiple types of applications to be able to work on different pipelines. Whereas Cape is going to just take your Kubernetes manifest. There is no extra effort needed. So we'll take the native Kubernetes manifest and then extrapolate into multi-cluster. So that is the advantage with Cape, where you don't need to build that extra pipeline to be able to deploy. Now let's take a look. Like I said, if for you to deploy to all these clusters at once, we need to group them together first. So here we are looking at grouping all the clusters. I have already grouped this, but I'll show you the procedure. So I can say my federation, or like my Southeast Asia federation, and then select all the clusters that I want. So I'm going to say I want this cluster on this federation, and then create. So that will basically create a federation for you. Federation is nothing but a group of clusters with which you can deploy applications to. So now that my application, my federation is ready, next thing is I'm going to deploy applications onto this cluster. To deploy applications onto cluster, I'm going to take a sample go to do application here, the same application which we are discussing right now. I would like to show the application how it is. So this is a Kubernetes application. We have done nothing inside that to any no magic of Cape here. There is a deploy stateless folder, deploy folder, which has like Kubernetes manifest inside them. So these are the manifest files, nothing related to Cape at all. So we take this manifest and then deploy to multi-cluster at single shot. So to do that, first you have to connect that repository. Here I have connected that repository already just to save some time. Typically, you just need to put in here your repository. If it is a Helm chart, also you can use Helm chart and then repository name. If it is a private, you can add credentials here. I've already done that for you. And then once you have the repository connected, maybe you have multiple applications inside this repository. It may not be always a single application in one repository. So you have to define an application out of that repository. So in here, I have deployed an application already, but I would like to show again, as in I select the repository that I have created. Maybe I want to go for the master branch, and then I want to deploy this application onto a namespace called to do. This namespace is a namespace that is going to be created on all the clusters to deploy your workload. And then create next. And then you will choose deployment folder to which you want to deploy. So here you have seen all the manifests are in this deploy stateless folder. So I can just say deploy stateless here. And then you can pick a type of custom type of manifest files. Here it is purely Kubernetes manifest. You can also go with Helm chart. You can also go with customize. Many options are there. Okay, I create manifest, and then that's it. So my application is created. Just the application is not created. We haven't deployed yet. I would like to show how it is deployed right now. Pretty much these two are same here. I'm going to click on deploy here and deploy application. And then I'm going to name my application deployment as maybe a to-do app, and then select the application I would like to deploy. And the namespace, I'll pick to do 1 or to do 2, whatever you want. And then I would pick the federation now. So I have my application, and then this application I want to deploy to all the 3 clusters in the federation. Or I can say I don't want it on-prem. I just want it on the Malaysia cluster and then the Jakarta cluster, like that. Okay, and then next, you can deploy this. Once you deploy, these workloads will be synced automatically. As you have seen, we haven't done any changes. We did not touch any Kubernetes manifest at all. You can see slowly the application has been synced to all the 2 clusters automatically. You can see all went into green. Temporarily, they will be down and all, but you can see all went to green. That means your application has now been deployed to these 2 clusters automatically without you having to create any pipeline. And maybe next time in the next release, you want to deploy to all clusters, right? So I can do a new release. A new release can be a code change. It can be a cluster change, anything that you can pick up, or a branch change. It's up to you how you want to convert it into. So this time I want to deploy to all the 3 clusters, and then click on next and deploy. Now this should get deployed to all the 3 clusters. Let's take a look. So you can see now we have 2 clusters there and slowly going to 3 clusters. Okay, there are several advantages with this approach. Just like Kubernetes is declarative for the objects, in the same way, Cape is declarative in nature. That means you don't need to know the old state or the current state. You just need to know what is your desired state. Cape will do the difference for you. Like, let's say you added some objects and then renamed some objects. Typically, if you are creating a pipeline for your own, you are doing those changes manually in the pipeline, but whereas Cape will automatically take care of them for you. Okay, so you can avoid a lot of complexity around deploying and as well as changing objects, taking care of the high availability of applications. All these are included in the overall solution. So this is the deployment portion of it. Obviously, I wanted to show the backup, but it's somehow my laptop has an issue which caused some error, caused something, and then I was not able to show it today. But definitely, I would like to get your participation. Go to cape.sh where you can find documentation. This is cape.sh. Sorry. If you go to cape.sh, you will see the landing page, which has all the information that you need for starting the installation process, trying it out. So you can see this is the cape.sh website. Here you have all the instructions that you need for trying it on your own. Okay. But if you have any questions, we can go into Q&A, see if you have any questions. I don't know if there's a possibility to unmute and ask questions, but we'll definitely watch the Q&A section for any of your input, any of your questions that you may have with respect to disaster recovery or with respect to deployment. Both cases, you can ask questions.
Any questions so far?
Okay. Some of the items, I think Vijay, since we don't have any questions, I would like to share some more information on the migration stories. I've been part of several migrations which happened in Southeast Asia region, mostly on-premise to cloud kind of migrations, uh, complex around having the Kubernetes on top of OpenStack. Think of like all combinations of scenarios that you can attach with. Few things I found difficulty or challenging is uh, when you start with some version of Kubernetes, when it is already working, people try not to disturb that and then forget about updating the Kubernetes version, and then stick to that until there comes a time where everyone has to move to a new version. Since you are not doing the delta updates or the minor major versions frequently, suddenly you have to go to a very advanced version. And this becomes another, again, it's like another digital upgrade process, which takes longer time. My suggestion, do the upgrades frequently. Try to have high availability on the Kubernetes cluster so that um, the overall thing I would like to say is have a lot of automation around configuring your Kubernetes clusters. Don't do them manually with hand, so that you will be more confident when you are doing the upgrade process. And if you're able to do upgrade process, then you can be, of course, very easy for you to do the minor and major updates as well. Okay, so one key item: don't do any configuration manually. Try to avoid. Of course, it is not really possible, but try to avoid doing manual configurations on your Kubernetes clusters. If you're using cloud provider, it's just a click of button. You just click the button, and then most of the time it gets upgraded. But you need to make sure you have the high availability plan for your applications as well. So platform level, the cloud provider will take care for sure, but making sure the application is also highly available, maybe spreading across different zones, different node labels, uh, having a advanced scheduling for your critical application is very important if you don't want to face downtime during the upgrade process. Uh, when doing the migration itself, you are looking at deeper things like your API versions might have been changed. So you have a V1 beta 1 API version on your local, on your on-prem, but when you're moving to a different environment, you might have a totally different kind of versions. So it's good if you can just try it on your sample cluster, have use some existing tool to like Kate to basically do the automatically migrate all the API versions to a newer version or the target version, whatever you're using. Because Kubernetes is changing very, very rapidly, and API versions are also evolving rapidly. Uh, the Kubernetes community itself tries to keep the API versions very like stable, but definitely there are breaking changes, especially in the recent versions. There are breaking changes which are breaking a lot of other applications like Helm charts. Typically, whatever worked that for you in the 1 year ago, it might not work without the change of API versions like that. So this is one other thing you need to keep in mind when you migrate. And also environment related stuff, which we know already covered some of them, but I would like to I would like to share some more information on that is you're looking at a different kind of environment, as in the network policies might be different, the network plugins might be different, maybe the storage types are different when you move. So all these things which you need to keep in mind when you're migrating workload. Um, in the overall backup and recovery process, the application level backups is what we need to take, not the file level backups. If you keep that in mind, then you are able to make the process of workload migration smooth. You might be doing etcd backups and also uh, taking the application managed manually, like using scripts and then migrating. It's kind of a difficult process when compared to taking application snapshot all together at once and then moving that whole immutable snapshot to your new workload, right? There are several cases where the etcd restore doesn't go as planned because of the certificate issues, maybe, or because of the IP address issues. uh, you have to be lucky, or you have to be an expert to be able to do a in my view, everyone has their own opinions, but in my view, you have to be an expert in the operations to be able to migrate a etcd cluster onto a new environment. Whereas using tools like cape, we avoid all this complexity. Just tell us what the application's targets are, and then where to restore. And that way, we are not really uh, looking at the complexity of etcd at the infrastructure level, but we are dealing with the complexity at the application level. Okay. This is another tip I would like to share during the migration process. Also, the capacity wise, you should be looking at whether you have the real, you should plan for some um, like additional capacity just in case the migration has some issues with it, right? I've seen cases where you migrate onto the new environment, but you did not plan for the capacity well, and then it ran into issues after the cutover. So you should be also looking at extra capacity just to be sure, because you're migrating to cloud anyway, you can scale them down whenever you need. These are some things which I figured while working in the South Asian market, especially during the migration process. If just looking at the questions one more time, if anyone has any question. Okay. Yeah, if you don't have any questions.
Okay. Thanks, Chuck. Thanks a lot for, I think, sharing the extra information. So if anyone has any questions, please do feel free to reach out to us. I think just to kind of close off the session, thanks everyone for your time. And as mentioned, we will be sharing both the free course on Alibaba's Cloud Academy with you, on using Kubernetes to manage containers and cluster resources, as well as our half-day assessment. So both these will be emailed to you. As mentioned, I think both Vinod and Chuck are actually coming in from their perspectives on running cloud projects. So please feel free to reach out to us if you have any requirements. And BigMind as well as Alibaba Cloud are very happy to jump in and be of help. Enjoy your rest of the week and have a good weekend ahead. Thank you so much for your time today.
Thank you.
Thank you.
Everyone.